So let's take a look. I have an equation, I have a function. What form is this equation written in? Let me make it a little bit bigger. What form is this in?
Standard.
It's in standard form. How can you tell when something is in standard form?
There's no parentheses.
You got it. That's the biggest giveaway, okay? So we know that this is standard form. Because there's no parentheses. You can also say that it's what type of expression do we call this?
By trinomial.
A trinomial. And what type of exponent do we always look for?
What type of
Exponent.
exponent too?
Yeah, exponent of 2. So all of those are good clues, good giveaways for why we know that this is in standard form. So any questions, any quick questions on what standard form is or how to notice if something's in standard form? Okay. And the way, yeah, so the way that it's written really gives it away. There's no parentheses, right? So you can already tell that it's ax squared plus bx plus c. That's what standard form is. So when you have a standard form equation, what's one thing that you already know about the function just by looking at the equation?
We already know the y-intercept.
Good. Where is the y-intercept supposed to be?
Behind the variables, like at the end.
At the end. And what do we call that number?
A constant.
Good. The constant is the y-intercept. So the y-intercept should be -6. Now I'm going to zoom in and let's check it out. -6, -6, -6, and maybe -6. I think it's almost on the -6. So can we really, what was that?
I think like if you go to the beginning, it's going by 2, but they didn't show the 2 or the.
Yeah, this one's going by 2s. Yeah, they're all going by 2s. So we just got to be a little careful when we look at it. Well, okay, let me zoom in really close. Is this one passing through the -6 or not? What do you
No,
guys think?
it's sort of like it's passing by right by.
Let me one more time. This is the -6 right there. So it's like a little bit, yeah, I see a gyro point. It's a little bit.
7.
Yeah, I think so too. I think so too, RL. It's a little bit lower than -6. It's hard to tell, but we can get rid of this one.
And we do have to get rid of it because it's not a negative, so it's not downwards.
So that was the other thing I was going to point out. We know the y-intercept, but what's the other big clue that we are given with this equation? What else do we know?
It's stretched. And
it's a stretch.
Reflected.
It is reflected?
No.
It's not reflected. So this is our A. A equals 2, which tells us that, just like you said, it's stretched. And what else does that tell me? It's a +2, so
it's not reflecting. It's going upward.
It's going upward. So we already got rid of D, but now we're sure that it's not D, and we're also sure that it's not
C.
Both of those are definitely out. So if you gave me a guess, if you were not sure which one it was going to be, if you told me A or B, I was happy with your answer, because as long as you can get rid of C and D, those are, if you chose C or D, then that was a bad guess. Okay, because between A and B, those are the only ones that match the equation. Okay, both of those are upwards, both of those are passing through -6. But now it's a little bit hard to tell between the two of them. We know that it's a stretch. So which one is a little bit more stretched?
A.
A
B
is a little,
looks normal.
B looks a little more neutral, A looks a little more stretched. But if you wanted to be absolutely sure, what other piece of information would you have to look for?
The vertex.
The vertex. And how do we find the vertex when you're in standard form?
We have to break it down, and we have to do the h equals -b divided by 2 parentheses. I mean 2a.
Good. So we use our vertex formula. H equals -b over 2a. So we know that a equals 2. What's b?
5.
B is 5. I'm going to plug those numbers right into my vertex formula. -b over 2a. Oh, why did I just write b? -5, that's what I meant, over 2 times 2. What do I get?
This was hard for me. And you get 5 divided by 4 negative, or -5 over 4.
-5 over 4. So that's a fraction. That is a fraction, but we can work with it. We can work with it because -5 over 4 is going to be between which two numbers? Think about it.
1 and 2.
1 and 2, but negative. Between -1 and -2. Think about it. -5 over 4 is a little bit more than -4 over 4. 4 over 4 is 1. So 5 over 4 is a little bit more than 1. But since I'm in the negatives,
-1/2.
it's not -1/2. It's going to be negative. Does anyone want to tell me? On decimal form, what would this be? -1 point what?
5.
Not 1.5. Juan's got it. 0.25. Yeah. Think about it like quarters. If you have 5 quarters, how much money do you have?
5 quarters?
Mm-hmm.
5 quarters. That will be $1.25.
So there you go, 1.25. So I know that the h value of my vertex is -1.25. So the vertex is at -1.25 comma something.
-6.
Did you plug it right back into the formula?
Oh, I did the opposite. I thought you couldn't simplify the fraction, so I put the fraction in the expression.
You can do that. You can do that too. But here's the thing, you don't have to. And let me show you why. If the x value is -1.25, that already gives us a lot of information. I know that the vertex for both of these, we can sort of estimate it. What's this? Think about where these are located.
A is like
-2. Oh.
A is like after the 2. No, A is before the 2, and then B is after the 2.
Yeah.
A is before the 2, B is after the 2. Actually, B is kind of like right on the 2.
B is -2, -12.
Yeah. Is that a 12? Yeah. -2, -12. Whereas A is somewhere between 0 and 2. Somewhere between 0 and 2. So
-1.
maybe around -1-ish, comma negative. It's right under the -8, so -9-ish.
-10.
Well, the 10 would be if it was right on the line.
Okay.
It's a little bit in between. So which of these fits a little bit more closely with what we have? It should be negative 1.25.
A.
A. A is closer because B is on the -2. It's like right smack on the -2. But we know it should be on the negative 1.25, so it's not B, it's A. So that was how you could figure out more exactly which one it's going to be. But if you took a guess and you were like, oh, okay, it's facing upwards and it's stretched out, that looks like A, you would have gotten the right answer anyways. So see what I mean? That's kind of like the moral of the story, okay? You can do it as exactly as you want, and that will give you the right answer. But if you know all of the different characteristics of what it should look like, 99% of the time, you're going to get the right answer too. Okay, so that's why it's super important to understand what those different numbers are telling you, because they can already give you the right answer without having to do any math. Any questions on this problem? I know that this one was a little bit challenging, so I want to make sure that I clear up any questions that you guys have. Okay. All right. So today we are going to do our last form. I know that we've been doing forms all week. We did vertex form on Wednesday. We did standard form yesterday. And today we're doing the last one. It's called factored form. But I think you guys will like this one. It's not as bad as the other two. It doesn't involve as much mathematics. So we ready? On this beautiful Friday, let's get started. So quick review of x-intercepts, because we haven't talked about them in a while. I want you guys to take a look at the following graphs and determine the x-intercepts, which, by the way, don't forget it, you can also call them zeros, roots, and solutions. They all mean the same thing. So all those keywords are the same thing as x-intercept.
Write it down.
Yes, I would definitely write that down. So x-intercepts are also called zeros, roots, and solutions. And once you've written that down, start taking a look at this problem and let's identify where the x-intercepts are located for these two graphs. So for the first graph, where are my zeros located? Look carefully.
-4 and there's 0, 3. I mean, 3. Yeah.
So you're correct with the 3, but look on the other side again.
-2.
-2. Yeah, it's on the 2.
Oh, I did it wrong. I thought it was like it went from -3 to -4.
Oh, oops, you went the wrong way. Okay, so that's 3, 0 and -2, 0. So the zeros are x equals 3 and x equals -2. And I'm writing it this way for a reason. We'll talk about that in a little while. But my zeros, I'm just talking about the x value. So one of them is x equals 3, the other one is x equals -2. How about on this graph? Where are the zeros?
0,
0,
the origin,
2,
and 2.
0, 2,
and about like right after -3.
a little bit after -3. Let's just call it -3 for now. So -3, the origin 0, 0, and 2, 0. So my zeros are x equals -3, x equals 0, and x equals 2. Now, which of these graphs is quadratic?
Quadratic.
Mm-hmm. Which of these is a quadratic graph? One of them is, one of them is not.
Graph A.
Graph A is quadratic. How can we tell?
Oh, because of its shape.
Yeah, because of its shape. It's what do we call that shape, that U shape?
Pabalos.
Nope.
Parabola.
There it is, parabola.
Oh,
It's a
sorry.
parabola. That's okay. So this is called a parabola. It has a name. Now, on the other hand, it's not a quadratic graph. We call this one, we don't need to know this type of graph, but it does come up sometimes. So it's good to know what it's called. This is called a cubic function. So it's not quadratic, it's cubic. How many zeros does this quadratic function have?
3.
3.
The quadratic,
Oh,
2.
2. The cubic one has
3.
3. Okay. So will a quadratic graph ever have 3 zeros?
No.
No. Quadratic graphs can have,
Infinite or negative infinite.
but the amount of zeros it can have 2, like we're seeing on it right now. What's another possibility that we've seen? It can have 2 zeros. What about the parent function? Think of the parent function. How many zeros does the parent function have?
It doesn't like. Does it go to? It does go to the 1.
1, yeah. Parent function looks like this. And where is the 0 located?
0.
At the origin, at the vertex. So sometimes you might only have 1 0. And sometimes, what if your parabola is up here like this? How many zeros would that one have?
None.
None. Yeah. So you can have 2, you can have 1, or you can have no zeros. Those are all the possibilities for quadratic graphs. Okay? So it can't have more than 2. That's the biggest takeaway. If it has more than 2, it is no longer quadratic, it would be cubic instead. All right, one more little thing I just want to explain because somebody asked it in the chat is why do we call it all these different things? So we call it zeros because that's the 0. Remember that the x-axis, we call that 0. So when it touches the x-axis, that's why we call them zeros. We call them also roots because, remind me, what is the exponent that you have for a quadratic function?
2.
Exponent of 2. Well, the exponent of 2, the opposite of that would be to take the square root, right? So we call them roots because if you want to find them, sometimes you're going to have to take the square root. And we won't do that yet, but we'll do that in the future. And then we also call them solutions because when you're solving an equation, you want to know the value of x. So the solution is x equals 3. So those names, they have different names for different reasons. But just remember, the most important thing is I want to make sure that you write them down so that if you see them out in the wild on a question, you know what they mean. If they're asking you what are the roots, they're asking you for the x-intercepts. If they're asking you what are the solutions, they're asking you for the x-intercepts. If they're asking you what are the zeros, they're asking you for the x-intercepts. So any questions on anything on this page? Okay. All right, so now we can get into factored form. Factored form, like I said, this is the last type of form that we're learning about. We've done vertex form. What does vertex form tell you about a function just by looking?
How the shape and size?
Shape and size
Translation.
and more importantly than all of that, it tells you one specific place on the graph.
The vertex?
The vertex, yeah. Vertex form tells you the vertex. What does standard form tell you?
Why?
The y-intercept. Well, factored form tells you the x-intercepts. So let's talk about it. So what's similar about factored form? From all the other forms we've learned about, what's the same?
It has a.
It has A. A is still the same A. So what does A always tell us?
Shape and size, leading coefficient.
It's the leading coefficient. It tells us the width, and it also tells you the
Direction.
direction. This is all the same as all the other types of forms. So this is nothing new right now, right? If A is greater than 1, what's happening?
It's greater than 1, then it's going to be stretched.
It's a stretch. If A is between 0 and 1,
0, compression.
compression. And if A has a negative in front of it, if it's less than 0,
Compression.
not compression,
Reflection. Oops.
reflection. There you go. So all of that is exactly the same as vertex form and exactly the same as standard form. Nothing changes. But then we've got these two guys right here. We call those our factors. It's called factored form because it shows us the factors of the function. And what you can do with the factors, and we'll do this a few times. We'll do this a lot today, so you'll get used to it. But what you can do with these two factors is you're going to set them equal to 0. So x plus m is going to equal to 0, and x plus n is going to equal to 0. And then if you solve for x, I'm going to subtract m on both sides, which is going to get me x equals negative m. And the same thing over here, I'm going to subtract n on both sides, and I'm going to get x equals negative n. And those are my solutions. Those are my x-intercepts. So go ahead and write all of that down. I know it kind of feels like a lot, but trust me, once we have numbers in our examples, it's going to be actually super, super easy. Everybody, in all the years I've ever taught, they love factored form the most because it's kind of the easiest one to work with. So just take a moment, write it all down, and then we'll talk.
Before.
What's up?
This reminds me of something we've done before.
It might remind you of solving equations because we're going to be doing that a little bit. Okay, take about 30 more seconds. And at this time, does anyone have any questions? Is there anything that I can clear up before we keep going?
Are we going to be plugging in numbers for x, m, and n?
We will for A, M, and N. So remember, usually with functions, the letter X is just, we keep it as an X unless we have an input value that we want to plug in. Okay, but we'll see literally on the next slide.
Okay.
Okay, anyone still writing? All right, so what's the deal with this? So here are some examples. So here's a few examples. We're going to find the roots of each function by setting the factors equal to 0, just like I showed you on the previous slide, except now we have actual numbers to work with. So remember what each of these two binomials are my factors, okay? So in order to figure out what are the x-intercepts, I'm going to take my factors and each one split it up and set it equal to 0. And then I have these two like mini little equations, which I'm trying to solve for x. So looking at the one on the left, what should I do to both sides to get x by itself?
Add.
Yeah, we can add 15 on both sides. So I get x equals 15. What about on the one on the right side?
Subtract 7.
Subtract 7 on both sides. What's 0 minus 7?
-7.
Negative 7. Yeah. And those are my two x-intercepts. So actually, I'm going to just save a little bit of room. Hold on a second. Those are my two x-intercepts. So x equals 15, x equals -7. Those are my x-intercepts. So it's super, super simple. It's a one really quick, tiny, mini little equation, and boom, you can figure out the x-intercepts of the function. Do I have any questions on that so far? Okay, let's do the next one on to the right. Let me label these. So number 1, let's do number 2. Same thing. There's only one key little difference in this example. What's different about number 2 that
We have an
didn't
A.
have? Yeah, we have an A. So remember, the A is there to tell you certain things about the function. So if A equals 4, what do I know?
It's upward.
Upward and
It's going to stretch.
upward and stretched. The A is not part of the x-intercepts. It's just sitting out in the front. We don't really need to do anything with it because the only thing we got to do is we got to take the factors, and the same way we did it in the previous example, we're just going to take those out, make them equal to 0, and then do a quick little equation. So on the left side, I would need to add 1 to both sides. So I get x equals +1. And what do I get on the right side?
X equals -3.
X equals -3 because I got to subtract 3 on both sides. And those are my x-intercepts. Remember, we can also call them zeros. So these are my zeros. So it's really not too bad, right? Not too bad at all. So before we do the next two examples, I want you guys to see if you notice any kind of shortcuts that maybe you could take instead of solving it the long way. Does anyone notice a pattern or a shortcut that you could take?
Just flip the number.
Yeah, just flip the number. So take a look. I have a +15. I started with a -15. I have a -7 where I started with a +7. So Obviously, you know, the long way will always get you the right answer. And if you don't want to take the shortcut, if you just want to do it the long way so that you're sure that you got it right, go for it. Do the long way. But if you feel like you get it with the shortcut, if the shortcut works for you, then use the shortcut. It's your own choice. You can choose whichever option you want to do. But go ahead and do number 3 and number 4. Take about 1 minute. Go ahead. Yeah, I love shortcuts too. But I always say you got to know why it works. So as long as you know why you can take the shortcut, then feel free to do it. And if you feel like shortcuts mess you up, then do it the long way because you know it's going to give you the right answer. Yeah, do 3 and 4 and you can send me your answers in the chat. Okay, like 15 more seconds. Should be pretty quick.
Seconds.
And 5, 4, 3, 2, and 1. Cool, good. I'm seeing all my answers seem to look correct in the chat. So nice job, guys. The quick way, you can just remember that it's the opposite. So this would be x equals positive 10 and x equals positive 6. But if you want to do it the long way, just set it equal to 0. So x minus 10 equals 0, x minus 6 equals 0. You got to add 10 to both sides. And here you had to add 6 to both sides. And then for number 4, who wants to give me the answers for number 4?
X equals 13
Mm-hmm.
and X equals negative 12.
Good. Perfect. So same exact thing. You can do it the quick way, just switch the sign. Or if you want to just make sure you're doing it right, set it to equal to 0, add 13 on both sides, set it equal to 0. Oops. X plus 12 equals 0, and subtract 12 from both sides. So for those, anybody have any questions on those answers? Good. All right. So now that we know how to kind of figure that out, we're going to be able to graph things pretty easily. However, hold on, let me just see what's going on. Yeah. However, if I wanted to graph these functions, I know the x-intercepts, which is great, but what am I still missing? What's like the most important point on the graph?
Important point on the graph.
The vertex?
The
Yes.
vertex, right? So I know where the x-intercepts are, but if I wanted to graph this, I can't because I don't know what the vertex is. So luckily, we can convert this from factored form to standard form. Pretty easily, actually. You guys already probably see how we're going to do this. What operation can I do between these binomials?
Foil.
We can FOIL. So just by foiling, you can turn factored form right into standard form. And then we'll talk about how we go from there. So we can FOIL. X times x.
2x,
Careful. X to the power of 1 times x to the power of 1 gives me
x to the power of 2.
of 2. Good. X squared. X times positive 1.
1x,
1x. Negative 2 times x.
Negative 2x.
Negative 2x. And negative 2 times positive 1.
Negative 2.
Good. So here's what I get when I FOIL. What do you guys think? What should I do next?
Add like terms.
You got it. We're going to combine like terms real quick. 1 minus 2, what do I get?
1x.
Careful, 1 minus 2.
1 minus 2, negative 1.
Negative 1x. And what's the last thing I got to do? I still have parentheses.
Distribute.
Yeah, we're just going to go ahead and distribute. And then boom, we'll be in standard form. Here we go. So 5 times x squared, I get 5x squared. 5 times negative 1x, I get negative 5x. 5 times negative 2, I get negative 10. So I started off with my factored form. Now I have standard form. Now let's just summarize what is everything I know about this function. What's one thing I know?
The y-intercept.
Yeah, what's the y-intercept?
Negative 10.
Negative 10. So I have my y-intercept. What else do I have?
X-intercept, which is positive 2 and negative 1.
Positive 2 and negative 1.
How'd you get that?
How did we get that, Jaira?
I went back to the original equation, the factored form, and then I just flipped the signs on both binomials and I got the answer.
Exactly. Exactly. So
Oh.
just like we did all of this examples, right? Same thing. So we have our y-intercept, we have our x-intercepts, and there's one other important piece of information. What else do I know?
You could get the vertex.
We what?
Oh no, we know A still is the same, and we could also get the vertex.
So we know that the A doesn't change. A is 5, so what does that tell us?
It's stretching and it's upward.
Stretch and upward. But what do we not know currently?
The vertex.
The vertex. Still don't know the vertex, but what can I do to find the vertex?
Turn it into vertex form.
There's not really, we don't have a strategy for that yet. So not that, but there's something else.
You can try to do the formula for the vertex.
Yeah, we have a formula. Remember? We have a formula. What is that formula again?
H. Oh no, yeah.
H
Wait,
equals.
question again?
Yeah, so H equals.
Oh, H equals negative B divided by 2A.
Exactly. So we can use that formula to figure out where the vertex is. Now we're not going to do that right now because I want to just practice more than anything. I just wanted to practice how to go from factored form to standard form, but we will use the formula on the next slide. So keep that for later. So go ahead and now take a look at number 2, and we're going to do the same exact thing. I want you guys to use what you know about FOIL to turn it from factored form to standard form, following the same steps that we did in number 1. Go ahead and take about a minute, maybe a minute and a half, we'll see, and go and get started. All right, that is time. If you're finishing up, finish up, but I do want to go ahead and go through it. So we're just going to FOIL real quick. X times x.
X squared.
X. Good. X squared. X times 3.
3x.
3x. X times 6, or 6 times x.
6x.
6x. And 6 times 3.
18.
18. I love it when it's all positive numbers. Nice and easy. Now we combine like terms. 3 and 6.
9x.
We got 9x. And finally, we can distribute our 2. So what do I end up with?
X to the power of 2
Mm-hmm,
plus 18x
mm-hmm.
plus 36.
Plus 36. Beautiful. All right, now let's list out everything we know about this function. Go ahead and anything you want to shout out, go ahead and shout it out. What do we know?
The y-intercept,
Is
36.
36. Good. What else?
A is 2, stays the same.
A equals 2. Does it stay the same? Oh, yeah. You mean, yeah, I got what you mean. Yeah, the A from the beginning is the same A we got at the end. And what does that tell us?
Stretches and it's upwards.
Upward stretch.
The x's are -6 and -3.
Perfect. Okay, hold on. Can I spell upwards? Maybe. All right, the x-intercepts are -6 and -3. And how did we get those two numbers again?
By flipping the numbers we start with.
Flip the numbers you started with. And what do I not know?
The vertex.
We don't know the vertex. We got to find it. Cool. Any questions on how to turn it from factored form to standard form? Notice it's very similar to what we did yesterday where we had to turn it from vertex form to standard form. Very, very similar steps. So that's kind of nice, right? Because that similarity means that it's going to be a little bit easier to remember what to do because it's pretty much the same. All right, so now, which of the following is the correct standard form for this equation? Go ahead and work it out on your own, and you're going to answer it in the poll. There's only one correct response, but the poll is like multiple choice, multi-select, but only click one option, okay? There's only one correct response. And I know it goes up to F. That's just because I couldn't change that. But go ahead. All right, I see 5 answers in the chat, 6 answers in the chat. That's almost half the class. Take another 30 seconds. And whoever chose F, you're not that funny. Just saying. All right, give me your final answers in 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All righty, guys, not bad at all. Let's take a look at the results. 75% chose the correct response. And I had a few people choose B, but I have a very good idea of what happened there. So we'll talk about that. But for the majority, nice job. All right, let's take a look. So first thing is we FOIL. Let me do that. Whoa, what just happened? That was weird. Okay, good. Okay, we're gonna FOIL real quick. And I'm just gonna go ahead and do this really quick. So x times x, I got x squared. X times -5, I got -5x. -8 times x, I get -8x. And then -8 times -5, 2 negatives, give me +40. Then I'm going to combine like terms. -5 and -8 give me -13x plus 40. So those of you who chose answer B, answer choice B, you have this, but I think you maybe forgot to distribute. You forgot about that 3 that was right in the front. So we can't forget him. He's very important. Okay, so if you chose B, I have a feeling that's what happened. But now when we do distribute, we're going to just multiply everything times 3. So I get 3x squared minus 39x plus 120. So answer choice C was correct. Does anyone have any final questions on how to turn it from factored form to standard form? All right, awesome. Okay, so now let's go ahead and move on to this one. Now we can kind of start putting things all together and we can graph. But we're going to see what happens, what we're missing, what we're going to have to do to figure it out, and then how we're going to be able to graph it. So we're going to start off by graphing the x-intercepts. Since I have this in factored form, what are my 2 x-intercepts?
+5
5.
and -2.
+5 and -2. Now remember, those are coordinate points, so this is 5, 0 and -2, 0. So there's my -2, there's my 5. It's going by 2s, so the 5 is in between 4 and 6. All right, and then remember what we said, we're missing the vertex, but the vertex is really important because without the vertex, I don't know if this is going to be wider like this, or is it going to be super skinny like that? It's kind of, you can't really know. Without the vertex, you won't know where the function goes. So we're going to have to turn this into standard form real quick using FOIL. So FOIL, I get x squared plus 2x minus 5x minus 10. And when I combine like terms, what is +2 minus 5?
-3.
-3x minus 10. Okay, so now I have a little bit more info. What else do I know now?
The y-intercept.
Yeah, I know that the y-intercept is 10. negative 10. Negative 10. So I'm going to put that as well. So I'm a little closer to my final answer, but I still need the vertex. So we're going to use the vertex formula. So I have my standard form, and let me actually put a little sticky note so that I have room. Okay. Ooh, I'm going to have to delete these for a moment. All right, vertex formula. H equals negative b over 2a. So what's my a?
1.
1,
Good. What's my b?
negative 3,
And what's my c?
negative 10.
All right, we plug everything in. So b is negative 3 and a is 1. So negative negative 3, what do I get in the numerator?
Positive 3.
Positive 3. And 2 times 1, I get 2. So my h, the h value is 3 over 2. It's a fraction. That's okay. We're going to work with it. What do I do with that fraction? I got my answer. What do I do with that number?
You kind of like estimate or like round.
There's a more, I can actually get the exact answer. Oh, do you mean round, like make it a decimal?
Yes.
I can do that. I can. I'm going to leave it as a fraction. But what do I do with the number though? Where do I put it? Because I have my h value. What do I need now?
The K.
Okay.
The k. So what do I do to get k?
Plug it in.
There you go. We're going to plug in 3 over 2. And we're going to plug it into our standard form equation. So y equals x squared minus 3x minus 10. So it's, like we said, 3 over 2. And you know what? I'll be nice. I'll be nice. We can do this using our calculators. So let's use what's the fraction form of, or what's the decimal form of 3 over 2?
1.5.
Yeah, 1.5. 1.5. Okay. What is 1.5 to the power of 2? You may use a calculator. One point five times 1.5. What do we got?
2.25.
2.25. 3 times 1.5.
Negative 4.5.
Yeah, negative 4.5. And then minus 10. So again, you can use your calculators. Go ahead. What is 2.25 minus 4.5 minus 10?
Negative 12.
Negative 12. Negative 12. I feel like there's a decimal there. 2.25 minus 4.5 minus 10.
Oh, negative 12.25. I did something wrong on my calculator.
There you go. Negative 12.25. So K is negative 12.25. And we knew that H, when we turn it into a decimal, is 1.5. All right, I'm going to leave that up for a moment. See if you have any questions. Anybody? Okay.
I'm just copying the rest of the sticky note.
Okay, so take a couple more seconds for that. All right, so now we can pretty much put everything all together. So I'm gonna have to delete this sticky note in order to graph it. So does anyone still need to write anything down? All right, so real quick. All right, so my vertex, now I know my vertex is at 1.5 comma negative 12.25. Now I have everything I need. 1.5 comma negative 12.25, I'm gonna estimate it somewhere around here. Y-intercept is negative 10. And my x-intercepts are 5 and negative 2. So putting it all together, there is my parabola. I always draw mine, they look so much like a V, but it should be more of like a U shape. It's kind of hard to do it. So in order to graph it from factored form, it kind of takes a lot of work, doesn't it? Because having to convert it into standard form and then having to use the vertex formula and like all of those extra steps, they take a kind of a long time. So how do you guys feel about doing a little shortcut?
Good.
You feel good about that? Anybody object to that? Any objections? Okay, that's what I thought. So let's take a look at a different example, and we're going to use a shortcut. Okay. So the first thing I'm going to do is I'm just going to graph the x-intercepts like normal. That's the easy part. What are my two x-intercepts?
1 and 3.
Positive 1 and positive 3. So 1 comma 0 and 3 comma 0. Here and here. Now, remember, I'm going to do a quick little sketch of this parabola. I know that because a equals 2, what do I know? Which way does it face?
Upward.
It's upward. It's a little stretched, right? So I'm just going to do a little sketch. It's not by any means perfect, but I just want you guys to notice something. That's my parabola, right? And actually, let me do this in black so that I can use different colors. Here's my parabola. I don't know where the vertex is, but it could be somewhere around there. Remember that parabolas are symmetrical. What runs down the middle? What's that called?
Axis of symmetry.
Axis of symmetry. So TBT, right? We haven't talked about it in a while, but here it is. The axis of symmetry. This axis of symmetry passes through which number on the x-axis?
2.
The 2.
The 2. X equals 2. That is the value of h. It's the same number as h. H equals 2. Why is that? Why are they the same thing? Think about it.
Because they're reflected.
It is reflected. That's not false, but I'm thinking of a different reason. Like, how do I know that this number, this 2, is also the same number for the vertex?
The line passed through the vertex.
The line passes through the vertex, exactly. So I don't know exactly where the vertex is, but I do know that it's going to be 2 comma something. Because that's what
Is it always going to be like that number?
it is. It's always going to be that number. And specifically, the number 2 is between the two x-intercepts, right? 2 is right smack in between 1 and 3. So if you know the x-intercepts, if you know what they are, you just got to find the number in the middle, and that's your h. How does that sound? Kind of easier, right? Maybe. We'll do a few examples. But if you know your h, what can I do with it? I have an equation. What should I do with that number?
Plug it in.
Plug it in. Plug it in for x. So if I know that h equals 2, I'm just going to plug it right in and do a little bit of math, and I'll figure out the value of k. So 2 minus 1. 2 minus 1?
1.
1. 2 minus 3?
-1.
Negative 1. All right. 2 times 1 is
2.
2, and 2 times negative 1?
-2.
Negative 2. There's my k value. So with just a couple of steps, I know my vertex is at 2, -2. So I was a little bit off, wasn't I? I was not in the right place. But let's go ahead and put it in the right location. 2, -2. And we're done. So there's a hard way to do this type of problem, and then there's a much easier way to do this type of problem. How do we feel about the easy way?
Good.
Not too bad, right? Let's do a few more examples. I know that we're kind of getting the hang of it, but do I have any questions at this time? Cool, all right, let's do it. A couple more. Same idea, what are my x-intercepts?
2 and 6.
+2 and +6. What number is in between 2 and 6?
4.
4. The number 4 is right smack in the middle, right? Right smack in the middle. So I know that h equals 4, or hold on, let me write that a different way. I know that the axis of symmetry is at the 4. Since the axis of symmetry is at the 4, that means that h equals 4. What do I do with that number?
Plug it in.
Plug it in. And when you're plugging it in, you just plug it in for x. And do a little bit of math. What's 4 minus 2?
4 minus 2, 2.
Is 2.
2.
And what's 4 minus 6?
-2.
And what's +2 times -2?
It's
-4.
-4.
2 times -2.
Mm-hmm.
Oh, -4.
-4. So there's my k. And now I have everything I need. My vertex is 4, -4. And I can graph it. So this is why I said at the beginning that a lot of my students, they really like factored form because it's kind of the least amount of work out of all of them. There's only a tiny amount of math involved, but it's really not that bad. How do we feel? Any questions? Think about it for a moment. I'll give everyone about 30 more seconds. All right, let's do one more. One more. Actually, no, these are a little bit different. Sorry, I forgot. So for these examples, I have the factored form equation, and we're not going to graph it, but I want everyone to tell me what the x-intercepts are, the zeros, and then tell me where the vertex would be. So we're going to follow those same steps. Now, number one's a little different. I'm going to actually skip number one. We don't need to do that one. Let's do number two together, and then I'll have you guys try 3 and 4 on your own. So for number two, what are my x-intercepts?
-4 and +2.
-4 and +2. Now this one's a little bit harder because we don't have a visual graph in front of us, but I want everyone to think about it for a few moments and try to figure out what number is right smack in between -4 and +2. -4 and +2.
-1.
-1. -1. That's exactly right. So the number in between these two, that's my h, is -1. So think about it for a moment. If you couldn't get that answer in your head, what are some ways to get it? What's one way that I could figure this out? Yeah, I'm seeing it in the chat. If you kind of list out the numbers, so -4, -3, -2, -1, 0, 1, 2, and you can figure out which one's in the middle, it's -1. So that's one pretty good strategy. It's a quick little strategy, just list all the numbers and then figure out what's right in between. All right, so we got h is -1. Now what do I do with that h?
Plug it in.
Plug it back in. So y equals 2 times, I'll plug in for x, -1. All right, what is -1 plus 4?
3.
+3. What is -1 minus 2?
-3.
-3. 2 times 3,
6.
and 6 times -3?
-6. I mean, -18.
-18. There you go. So k is -18. So my vertex is at 1, -18. -1, -18. And that's it. And we're done. So I want you guys to try it out on the other two, but actually I don't want to take up too much time. So let's just do number 3. Just number 3. Take about a minute for number 3. All right. So let's go through it real quick. What are my x-intercepts?
-1 and -3. I mean 3.
-1 and +3, yeah. What number is right smack in between -1 and +3?
1.
+1. So h equals 1. Take that number, plug it in. Here's my 1. Oops. There we go. And 1 plus 1,
2,
2. 1 minus 3,
-2,
-2. -3 times 2,
-6,
and -6 times -2,
6,
-6 times -2,
+12.
12. +12. So my k is 12. Vertex is at 1, comma 12. So that's the process, and it can be pretty quick if you just make sure you're paying attention to all your negatives and your positives and doing your math correctly. How do we feel? Any questions? I have to move on, unfortunately, but do I have any final questions on this strategy? Awesome. Okay, so let's do a quick one. Yeah, try this one out. If the line x equals 3 is the axis of symmetry, which of these can possibly be the zeros, the x-intercepts? Try it out. All right, I don't want to spend too much time because we do have to move on. So give yourself 10 more seconds. Try your best to figure it out. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay. I'm not going to share the responses yet. I'm going to go over it first. X equals 3 is the axis of symmetry. So that means that wherever this is, 1, 2, 3, that's the axis of symmetry. Which means that the x-intercepts have to be equally distant from that place. All right? So what's in between? Let's go from the bottom to the top. What's right smack in the middle between -8 and -2?
-5.
-5. So it's not D. What's right smack in between -3 and +3?
0.
0. It's not C. What's right smack in between -1 and +5?
2.
2?
Oh, yeah, I think I messed up on this.
I believe it's 2, yeah. -5. And you can always look and think about it. So -1, 0, 1, 2, 3, 4, and 5. Cross things off.
Yeah, it's 2.
It's 2. What's right smack in between -1 and +7?
3.
2 and 3.
It's 3.
Oh,
And again, -1, 0, 1, 2, 3, 4, 5, 6, 7. Cross things off.
I did it wrong.
3. So answer choice A. And let me just graph it really quickly so you can see 1, 2, 3, 4, 5, 6, 7. There's -1, there's +7, and the axis of symmetry is right in the middle. That's what we were looking for. So they were giving you the line that was in the middle, and they were asking which of these options would it make 3 be right smack in the middle, and it was answer choice A. Now here's my results. So nobody chose A. Nobody chose A. I think maybe if you chose answer choice B, maybe you thought it was +1. Maybe. But if that was the case, then you got to make sure you're reading carefully. That was a -1, not a +1. Any final questions on this problem or on this, how to do this type of problem? Okay. All right, we're running low on time, so I'm sorry if I kind of rushed through this last part, but we're going back to these weird types of functions because they will come up and we got to be prepared for it. What are the zeros of this function? What are the x-intercepts? Look carefully. What are the x-intercepts?
-4, +5, and 0.
And 0, good. So don't forget the 0 is there as well. -4, +5, and 0. Well, we can figure out the correct response out of these answer choices by thinking about the pattern. Remember that whatever's in the parentheses gets flipped, right? So -4 is going to match with +4, and +5 is going to match with -5. So that cancels out a couple of, well, that cancels out one answer choice at least.
So
But
it's
now,
either B or C?
so it's
I mean,
probably
B or D.
B or D. But let's quickly take a look at one more thing. Do you guys notice that little X that's out here in the front?
Yes.
It's hard to, sometimes it's easy to miss. Let me talk really quickly about what that means. So X, if there's an X in the front, remember how we work with these. What do? We take each of them, and what are we supposed to do with them if we're doing it the long way?
Foil.
If we're finding the zeros,
If we're finding the zeros,
you
oh,
split.
Doing the opposite.
We're going to do the opposite, and we do that because technically we got to set them equal to 0. Remember doing that the long way, you would just set it equal to 0. Well, this X right here, I can set it equal to 0 as well. And I just get X equals 0. So I end up with X equals 5, +5. Oh, I missed my, that was supposed to be a 4. I'm sorry. X equals +5, X equals -4. And because of that little X in the front, we also get X equals 0. So the big takeaway, because this will come up on your test, I can't stress this enough, but it's not hard. It's just one little thing to remember, is that whenever there's an X in the front, that just means that you have X equals 0 as well. So for that reason, the correct response would be D. Now let's look at a very similar problem. Very similar problem. What are the 3 x-intercepts in this case? Look carefully. This one's a little hard because of the scale factor, but take a look.
Yeah. Um,
It's a little, it's a little hard, I know.
0.
Is it 0 though? Is it passing through the 0?
No.
No, so it's not 0. I'll give you guys a clue. It's going, each little line is 1/2, is 0.5.
Well, I know like the vertex is in the middle of 2. I think. I don't know.
But we're not looking for the vertex, we're looking for the x-intercepts.
I'm trying to calculate the x-intercept. I mean the x-axis.
It's going by 0.5s.
0.5s. Okay. 0.5. 0.10.
0.5 is 50 cents. What do you get when you get 2 of those?
$1
Okay, so where's this?
is right there where you.
So what is that number?
1.5. Wait, hold on. 1.
Just 1. That's 1, because it's 0.5, 1, 1.5. What comes next?
0.5, 2.
2.
Oh,
Now go the other way. Go the
This is-
other way.
this isn't that bad.
It's
Okay.
not that bad. Y'all just got a little tripped up. That's okay.
2.5 equals 3.
Next is 3. So this is -3. So my x-intercepts are x equals -3, x equals 1, and x equals 2. That was it. That's how easy it can be. But now, which of the factors would match? Factors. So remember, if you get a -3, it would match with a +1, +3. If you have a +1, it would match with a -1. If you have a +2, it's going to match with a -2. So which ones is it going to be?
B.
B. Because when you put these all together, it would be x plus 3, x minus 1, and x minus 2. So you have to remember to flip that sign. Questions? I know I'm rushing. I know, I feel bad, but it is what it is. Let's do one last one. I'm going to zoom in a little bit. I know it's a little hard to tell. But here's my equation. Those are the factors. Figure out what are the x-intercepts. Do that first. So what are my x-intercepts going to be? Based on the factors. Look at these numbers. What are the x-intercepts going to be?
+3 and -2.
Positive 3, -2, and 0. Because remember, when you have a little lonely x in the front, that means x equals 0. For that one, x equals +3, and for this one, x equals -2. So I have 3 x-intercepts. Now look carefully which answer choices are out.
C and D.
C and D are out because these only have 2 each.
And it is quadratic while we need a cubic one.
Yeah. We're looking for a cubic graph, so which one matches? 0, +3, and -2.
A. It's kind of matches, but I won't choose B anyway because it's like right it's far back from -3.
They basically, for letter B, they did it backwards. So it's A, not B. Okay, that was a lot of information, you guys. And I appreciate you guys for sticking with it. So I'm gonna make a quick edit, all right? Homework is still due tonight. Homework, as always, due Friday at midnight. There is extra credit, which I posted about on Teams, due Wednesday at midnight. And we didn't have time for our quiz, so what I'm going to do is I'm going to make it due Sunday at midnight. I'll post it and it'll be due Sunday at midnight. Now, if you can't get it done, I hate giving you guys work over the weekend. So if you can't get it done by Sunday at midnight, what should you do?
Type you in Teams.
Let me know. If you don't tell me, it's a Z. But if you tell me, I'll give you an extension. So don't give yourself a Z for no reason. If you can't get it done, that's fine. Just let me know. Sorry for the rushing at the end. You guys are all done. Have a great weekend. I'll post everything on Teams and I will see you guys on Monday, everyone.
Have a nice weekend, Miss Lopez. See you on
Thank
Monday.
you. See you Monday. Bye, everyone. Remind works as well, by the way. So you could do Remind or Microsoft. Okay, bye.